In the previous lectures, we've seen how to crack the WEP encryption in minutes, even if the target network is not busy. Now, in the next lectures, we will talk about cracking WPA and WPA2. First of all, before we start talking about how to crack these encryptions, it is very important to understand that both of them are very similar. The only difference between them is the encryption used to ensure message integrity. WPA uses TKIP and WPA2 uses an encryption called CCMP. In any case, this does not affect the methods that we're going to use to crack WPA and WPA2. Therefore, all of the methods that I'm going to show you from now on will work on both WPA and WPA2. Now, both of these encryptions came after WEP, and they were designed to address the weaknesses in it. Therefore, both of them are much more secure, and cracking them is more challenging. So, before we start talking about how to crack them, I want to cover a feature that, if enabled and misconfigured, can be exploited to recover the key without having to crack the actual encryption. The feature is called WPS. It allows devices to connect to the network easily without having to enter the key for the network. So it was designed to simplify the process of connecting printers and such devices. You can actually see a WPS button on most wireless enabled printers. If this button is pressed and then you press the WPS button on the router, you'll notice that the printer will connect to the router without you having to enter the key. This way, the authentication is done using an 8-digit PIN. So you can think of this as a password made up of only numbers, and the length of this password is only 8. So this actually gives us a relatively small list of possible passwords, and we can try all of these possible passwords within a relatively short time. Once we get this PIN, it can be used to recover the actual WPA or WPA2 key. So as you can see, with this method, we are not exploiting WPA or WPA2. We are actually exploiting a feature that can be enabled on these encryptions. So for this to work, first of all, we need WPS to be enabled on the network because it can be disabled. Also, it needs to be misconfigured, so it needs to be configured to use a normal PIN authentication and not a push button authentication. If push button authentication is used, then the router will refuse any pins that we try unless the WPS button is pressed on the router. Therefore, the method will not work if push button or PBC is enabled. So in most modern routers, PBC comes enabled by default or WPS will be disabled by default, so this method might not work. But because WPA and WPA2 are so secure and so challenging, it is always a good idea to check if WPS is enabled and try the method that I'm going to show you to crack the network. If it fails, then you can try the other methods that I'm going to show you after the next lecture. Okay, now that we know what WPS is and how it can be used to recover the password for WPA and WPA2 networks, let's see how to do that in practice. So, right here I have my Kali machine. I've already enabled monitor mode on my wireless adapter on Mon 0. Now usually we use AeroDumpNG to see all the networks around us. But right now we want to see the networks that have WPS enabled, but because like I said, it's just a feature and people can turn this feature off. So first of all, I'm going to use a tool called Wash to display all the networks around me that have WPS enabled. So we're going to do wash --interface and give it my interface in monitor mode, which is Mon 0. So all we're doing is wash is the name of the tool, interface to give it the interface, and Mon 0 is my wireless adapter in monitor mode. If I hit enter now, you'll see it'll list my network straight away. Now I pressed Ctrl C to cancel this, similar to AeroDumpNG, because it'll keep running unless you cancel it. And you can see this is my target network. It's called test AP. It's giving us the vendor of the hardware used in this network, in this access point. The LCK tell us whether WPS is locked or not, because sometimes WPS locks after a number of failed attempts. So right now this says no, which means that we can actually go ahead and try to guess the pin. It's giving us the version of WPS. It's using version 1. The signal strength is in here, the channel, and the BSS ID. Now, I explained the meaning of all of these things before in my AeroDump-NG lecture, so I'm not going to talk about them now. If you forgot the meaning of any of these terms, please go back to the AeroDump-NG lecture. Now, this network actually uses WPA2, so just to confirm this to you, if I go here to my host machine and just try to connect to it, you'll see that it's telling me that this uses a WPA2 password. But like I said, we don't care if it's WPA or WPA2 because we're going to be exploiting a feature in these encryptions, which is the WPS feature. So now that we know our target network uses WPS, there is a good chance that this attack will work against it. The only reason it might fail is if the target uses PBC or push button authentication. Like I said, if the target uses PBC, then it will refuse all the pins unless the button is pressed on the router, and therefore this attack will fail. The only way to know is to literally try this attack and see if it works. So I'm going to copy the MAC address of this network or the BSS ID. And the first thing that I'm going to do, similar to what we did with WEP, I'm going to associate with the target network using a fake authentication attack. So basically, I'll be saying, I want to communicate with you. Please don't ignore me, so that when I run the attack, the network will start accepting the pins and not ignore me. So to associate, we're going to use the exact same command that we used when we did it with WEP. So we're going to use AReplay-NG. We're going to tell it I want to run a fake authentication attack. We're going to give it the delay. So this is the time to wait between association attempts. Previously, we set it to 0 and we had to do this manually every now and then. Right now, I'm going to set it to 30 so that we associate with the target network every 30 seconds. Then I'm going to do -A to give it the MAC address of my target, and -H to give it the MAC address of my wireless adapter in monitor mode. And we've seen that we can get this by doing ifconfig and copy it from here. We said it's the first 12 digits. And I'll just replace the minus with the colon. And finally, I'm going to give it the name of my wireless adapter in monitor mode, which is mon0. So I explained this in details before. That's why I did it quickly. If you don't remember how I did this, please go back to the fake authentication attack lecture. So the command is ready now, but I'm not going to execute it. I'm going to go down to the bottom terminal and run Reaver, which is the program that will brute force the pin for me, and only then I will associate with the target, because otherwise AReplay-NG will fail to associate with my network. So I'm going to move to this terminal right here. I'm going to clear the screen and we're going to run Reaver, which is the program that's going to brute force the pin. So it's going to try every possible pin until it gets the right pin. Once it has the right pin, it'll use it to compute the actual WPA key. So using Reaver is very, very simple. It's very similar to everything we've been doing so far. So first of all, we have to type the program name, which is Reaver. Then I'm going to do --BSSID to give it the MAC address of my target network. So I'm just going to paste it. Then I'm going to do --channel and give it the channel of the target network, which is 1. Then we're going to do --interface and give it my wireless adapter in monitor mode, which is mon0. So a very, very simple command. We're using Reaver. This is the name of the program that will do the brute forcing for us and give us the key. We're giving it the BSS ID, the MAC address of my target. We're doing --channel to give it the channel that my target is running on. and we're doing dash dash interface to give it the name of my wireless adapter in monitor mode. I'm also gonna add two more options. I'm gonna add dash VVV to show us as much information as possible. This is really helpful. If it fails or things go wrong, we'll be able to know what's happening, why things are going wrong. And I'm also gonna do dash dash no associate to tell Reaver not to associate with the target network because we're already manually doing that in here. So Reaver can automatically do this step right here for you, but I've seen that it fails a lot. Therefore, it's actually better to do it ourselves manually here and then tell Reaver not to associate. So now I'm gonna hit enter to get Reaver to work. And I'm gonna go up to the top terminal and I'm gonna hit enter to associate with the target network, telling it please don't ignore us, so that Reaver at the bottom here can brute force the pin and try every possible pin until we get the correct pin, which we'll use to get the password. And as you can see right now, Reaver is trying the pin 1, 2, 3, 4, 5, 6, 7. And perfect. You can see the pin was actually 1, 2, 3, 4, 5, 6, 7, 0. So it's a simple pin. It actually came with this pin. So I didn't manually set this pin. My router came from the factory with WPS enabled with this pin. So like I said, this still works, but again, not against all routers. From that, it was able to discover the WPA key, which is UAU RWSXR, and the name of the router is test AP. So I can literally go ahead and connect with this password, and I'll be able to connect to the network and see and decrypt all of the packets sent in the air. Now, if WPS is disabled on your target network, or if it's enabled but configured to use push button or PBC, then the method that I showed you in the previous lecture will not work. Therefore, you will have to go and crack the actual WPA or WPA2 encryption. And like I said, when these encryptions were designed, the developers knew about the weaknesses in WEP and they made sure that they properly fixed these weaknesses. They actually did a pretty good job at this. Therefore, we cannot use the same method used in WEP to crack WPA and WPA2. So in WPA2, the keys are unique, they're temporary, they're much longer than what they were in WEP. Therefore, the packets sent in the air contain no information that is useful for us. So it doesn't matter, even if we capture 1 million packets, we can't use them to crack the key. The only packets that contain useful information are the handshake packets. These are 4 packets transferred between a client and the router when the client connects to the network. So, in this lecture, I'm going to show you how to capture these packets, and in the next lectures, we'll see how to use them to crack the WPA or WPA2 key. First of all, as usual, you'd want to run aerodump-ng against all the networks around you. I've already done that, and as you can see, this is my target right here. It's using WPA2, and this is the MAC address. I'm going to copy it. And the first thing we'll do is just run aerodump-ng on this network and store the data in a file, exactly the same way that we used to do it with WEP. So we're just going to do aerodump-ng --BSSID and give it the BSSID of my target, --channel, and give it the channel of my target, which is 1, --write, to specify a file name to store all the data that we're going to capture in. And let's call this WPA handshake, because we're going to capture the handshake. And finally, we're going to give it my wireless adapter in monitor mode, which is mon0. So, very simple command. We've done this multiple times by now. We're using aerodump-ng. We're giving it the MAC address of my target after the BSSID. I'm giving it --channel to specify the channel of my target. I'm using --right to store all the data in a file. This file will contain everything that we capture. So if we capture the handshake, it will be in this file. And finally, I'm giving it the name of my wireless adapter in monitor mode. So now I'm gonna hit enter. And as you can see, AeroDump-ng is working against my target network. And right now, all we have to do is literally sit down and wait for the handshake to be captured. Like I said, the handshake is sent when a client connects to the network. So we'll literally have to sit down and wait until a new client connects to the network. Once a new client connects, we will capture the handshake, and you will see in here AeroDump telling us that the handshake has been captured. Alternatively, we can use something that we learned before, which is a deauthentication attack. We know using that attack, we can disconnect a client from the network. So we can do this for a very short period of time. We can disconnect this client from the network. He will automatically connect once we stop the attack. Therefore, when he automatically connects, the handshake will be sent in the air and we will be able to capture it. This way, we will not have to sit down and wait for someone to voluntarily connect to the network. So, we've seen how to do this before, and it's going to be exactly the same command as we did it before. We used areplay-ng, we did --deauth, then we specified a really large number of packets to keep the client disconnected for a long period of time. This time I'm going to set this to 4 to only send 4 deauthentication packets. This way, my client will be disconnected for a very short period of time. They won't even feel that they got disconnected, but this is enough for the handshake to be sent because they will be disconnected, they will automatically connect, and when they do that, we will capture the handshake. Now, the next argument we want to set is the MAC address of my target. So we're going to do -a followed by the MAC address of my target. Then we're going to do -c followed by the MAC address of the client that we want to disconnect. So it's this client right here. I'm going to copy, paste it here, and finally we're going to give it the name of my wireless adapter in monitor mode, which is mon0. And we are done. Again, I've spent a full lecture on this command explaining what a deauthentication attack is, so if it's a bit confusing, please go back and revise that lecture. Basically, all we're doing is we're using areplay-ng to run a deauthentication attack to disconnect this device for a very short period of time. That's why I'm setting this to only number 4. Then I'm using -a to specify the MAC address of my target, -c to specify the MAC address of the client connected to this network, and then I'm giving it my wireless adapter in monitor mode. Now I'm going to hit enter and keep an eye on this side right here. You'll see the handshake will be captured in here. So we're going to hit enter. The authentication packets are being sent. And perfect. As you can see, once the client connected again, we received the handshake. So now we can quit AeroDump-ng, so Control-C, because we have the handshake now. It is stored in the file that we set after the write option, which is called WPA handshake. And in the next lecture, I'll show you how this handshake can be used to get the key for the network. From the previous lectures, we learned that when it comes to WPA and WPA2, the only packets that contain some information that can help us with cracking the key are the handshake packets. And in the last lecture, we learned how to capture the handshake and store it in a file. Now, the handshake does not contain any information that can help us to recover or recalculate the WPA key. The information in it can only be used to check whether a password is valid or not. Therefore, what we're going to do is to create a word list, which is basically a big text file that contains a large number of passwords. Then go through this file, go through the passwords one by one, and use them with the handshake in order to check whether this password is valid or not. You can actually download ready word lists from the internet. But in this lecture, I want to teach you how to create your own word list. And in the next lecture, I'm going to explain to you how the word list and the handshake are used in order to recover the password. And we'll see how to do that in practice. So in this lecture, we're going to learn how you create your own word list using a tool called Crunch. This is a really handy skill to have under your belt if you want to be a penetration tester, because you're going to face a lot of scenarios where a word list attack can become very handy. So using the tool is very simple. All you have to do is just put the name of the tool, and then you specify the minimum number of characters for the passwords to be generated. Then we're going to specify the maximum number of characters for the password. Then you specify the characters that you want to generate passwords from. For example, you can put all lowercase characters, all uppercase, you can put numbers, digits, or you can just specify a smaller number to make the word list smaller. You can also use the option T, which is an optional, to give a pattern. So for example, let's say that you are looking at the person while they were typing their password, and you've seen that the password will start with an A. So you can tell Crunch that the password will start with an A, and then give me all possible combination of passwords that start with an A. And after that, we use the -O option to specify the file name where the passwords are going to be stored. So we have a small little example here that will generate a list of passwords that start from 6 characters to 8 characters and contain these characters right here. So it's going to create combinations of 1, 2, 3, ABC, and the $sign. And it's going to store it in a file called word list. And these passwords are going to start with an A and end with a B. And it will generate passwords based on all possible combinations between the A and the B. So all of the generated passwords will always start with A and end with B. So let's have an example of the tool. Now the tool actually have a lot of options other than what we've seen so far. So if you just type in man crunch, you'll see all the options that you can set, and you'll see detailed description about all of these options. So it's actually really good. You can go ahead and spend some time to get familiar with the tool. Now I'm going to show you the example, and based on the example, you'll be able to run all of these commands. But if you want to run or create some advanced word lists, then I highly recommend that you go over this. One of the really cool options that I want to highlight is the -P option. The -P option tells Crunch to generate passwords that don't have repeating characters. For example, when you specify all lowercase characters, you specify A, B, C, D, it will start by generating passwords made of A, and then A, B, 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 and all of that. So when you do this, Crunch will actually ignore these type of passwords, and it will only create passwords that don't have any repeating characters. And that will reduce the size of the word list from the number of characters to the power of the length to the number of characters factorial. If you scroll down, you'll actually see more examples of commands and the type of word lists that will be created. So again, you can have a look on these and get yourself familiar with. Once you're done looking at the man, you can just press Q and you'll be out of it. And we're going to run our command here. So we're going to use Crunch. And I want to generate passwords of minimum of 6 characters and maximum of 8 characters. And I want them to contain combinations of A, B, C. And let's say the digits 1, 2. Now in here, you can actually keep listing things. You can list characters, you can list uppercase characters, or even symbols if you wanted to. Once you're done with listing the characters, we're going to specify the file to save it to. And we're going to save it in a file called test.txt. So the command is very simple. It's crunch, minimum length of the password, the maximum length of the password, followed by the characters that we want to use to generate passwords from, and then O to the file that the passwords are going to be stored in. I'm going to hit enter. And as you can see now, it's telling us that it generated 448,000 passwords approximately, and they're all stored in a file called test.txt now. The size of the file is 4 megabytes. And now I can open this file by doing cat test.txt. And as you can see now, we can see all the passwords that have been generated. I'm going to Control-C out of it because it's a huge file. And as you can see, it actually contains all possible combinations of ABC12. I also want to show you an example of using the -t option. So I'm going to set this to only 6 to 6, so it's only 6 characters. And we're going to use the -t option, which is the pattern option. And I'm going to tell it that I want the password to always start with an A. And then I want you to fill all possible combinations of characters between the A and the B. So I want passwords that start with an A and end with a B. And in the middle, at the @ you can fill all possible combinations of ABC12. Gonna hit enter. As you can see now, the number of passwords is much less. It's only 625 passwords because I've narrowed down the possibilities of passwords. Again, if I do cat test.txt, you'll see that I have all the passwords right here. So this is it. Tool is really useful, can be used in many scenarios. I highly recommend that you spend some time with it and also have a look on some of the existing word lists out there on the internet. Now, from the previous lectures, we learned in order to crack WPA or WPA2, we need to first capture the handshake and second have a word list which contains a number of passwords that we're going to try, and hopefully one of them will be the password for the target network. So right now I have both of these components and we are ready to go and crack the password. To do this, aircrackng is going to unpack the handshake and extract the useful information. The MIC right here, or the message integrity code, is what's used by the access point to verify whether a password is correct or not. So it's going to separate this and put it to the side, and then it's going to use all of the other information right here combined with the first password from the word list to generate an MIC, another message integrity code. And then it's going to compare this MIC to the one that's already in the handshake. If the MIC generated using this information plus the first password is the same, then the password used to generate this MIC is the password for the network. Otherwise, this password is wrong and it'll move to the next password. Again, it'll do the same. It'll use all of this information combined with this password, generate a new MIC, compare this new MIC to the one that's already in the handshake. If it's correct, then this is the password. If it's not, then it's going to move on to the next password. And it'll keep doing this through all of the passwords in my word list. If any of them generates the right MIC, then this is the password for the network. Otherwise, we won't be able to get the password. That's why the success of this attack really depends on your word list. So, let's see how to do this in practice. Right now, I have my word list right here. It's called test.txt. And I've actually manually added my password to the end of the list right here, just so that when I run the word list against the handshake, I will actually find the password, because the word list did not contain my password by default. I also have the handshake file right here, as you can see, and all of this is in my home directory, which is my root directory. So if I do ls in here, you'll see I have the word list and the handshake file. So we're ready to run aircrackng. So we're going to type the name of the program as usual, followed by the name of my capture file, which is wpa-handshake01.cap. So far it's identical to the way that we used to use it with WEP. The only difference right now, because this is a WPA2 network, we have to specify a word list with the -w option. And the name of my word list is test.txt. So very simple. Aircrack is the name of my program. WPA handshake01.cap is the name of the file that contained my handshake, and I'm using -w to specify my word list file. I'm gonna hit enter, and as you can see now, Aircrack NG is running through the word list, testing each word in the word list one by one, as shown in this diagram, calculating an MIC based on this information and the word list, and then if the MIC is correct, it's going to tell me that this is the password. Now, the speed of this depends on your processor and the size of your word list file. So if you have a huge file, obviously it will take you longer time. There are also online services that you can try where you upload the handshake, and they have huge word lists and they have supercomputers to run through these word lists and try to give you the password. Unfortunately, I can't share their links with you, but you can easily find them on Google if you search for them. And perfect, as you can see, we managed to find the key. It's telling us the key is found, and this is the key to the network. And this is the correct key because, as you know, this is the same key that we got when we exploited the WPS feature. So now we can go ahead and connect to the network, and we'll be able to run all of the cool stuff that I'm going to teach you in the post-connection attack section. Now, this is the only practical way known so far to crack WPA and WPA2 keys. There are methods to speed up this process, so you can use the GPU for cracking because it's much faster than the CPU. That's if you have a GPU. You can also use rainbow tables. You can also pipe the word list as it's being created in Crunch to Aircrack NG. This way you can create bigger word lists without using any storage on your computer. There are also methods so that you can pause your cracking process and then come back after a while without losing your progress. But the main idea is the same. The only way right now to crack WPA and WPA2 is through a word list attack. You can use social engineering, however, to get the password using an evil twin attack where you trick one of the users to give you the password. This is actually all covered in my advanced network hacking course. The cracking using the GPU, piping Crunch to Aircrack NG, getting the password using an evil twin attack, and much more advanced network hacking techniques. If you're interested in that, then I highly recommend you have a look on my advanced network hacking course. Check out the bonus lecture of this course, the last lecture of this course. It contains links to all of my other courses and the comparison between them. We saw in the previous video how we can use Aircrack NG to crack WPA encrypted passwords using a word list. In the previous video, Aircrack NG went through our word list. It combined each password in the word list with the ESSID to create the PMK using the PBK2 algorithm, and then compared the PMK to the handshake. If the PMK was valid, then the password that was used to create the PMK is the password we're looking for. If it's not, it just went to the next password and created a PMK from it. So Aircrack NG was creating the PMKs on the fly. The process of combining the password and the ESSID to create the PMK takes a good bit of time, so it takes the most time of the cracking process. Therefore, in many scenarios, while we're waiting to capture the handshake, in many scenarios we'll have access points that doesn't have any clients connected to it. So if we have something like that, we have to wait until someone connects to the access point to capture the handshake. So while we're waiting, we can actually save time by converting our word list to a PMK list. Because as I said, converting the password to a PMK takes the most time. So while we're waiting, we can change each password in the list and create a new PMK list from our word list. And then once we capture the handshake, we can use our ready PMKs, and the cracking process is going to be much quicker. We're going to do this using aerolibng. So let's see how it works. Okay, so our first command is going to be to create a new database and import our word list in that database. So it's going to be aero ng. We're going to create a new database. So let's call it test db. And we're going to import passwords. And we're going to put the name of our word list, which is called WPA word list. So very simple. Arrowlib is the name of the program. Test is the name of the database that we're going to create. And we're telling it to import passwords. And the passwords are going to be taken from a file called WPA word list. Gonna hit enter. And as you can see, a new database called test db has been created. And the passwords have been imported into it. So the next command we're going to do is we're going to import our ESSID to the database. So I'm just going to store the name of the ESSID of the target network into a file. I'm going to do this using a Linux command, the echo command. So I'm just going to say test ap. I'm going to echo it to a file, and I'm going to call the file test ESSID. So that's basically, so I'm going to read it now. Cat test ESSID. That's just making sure that the name is there. So this command, I just created a file and I saved the word test ap in that file. That's the name of my target access point. And then here I just read the file to make sure that it actually contains test ap, and we can see that it contains test ap. Now I'm going to import this file into my database. So we're going to use the same command that we used before. The only difference is we're going to say we're importing ESSID this time, and the name of the file that contains the ESSIDs is test ESSID. So again, arrowlib ng test db, that's the name of my database that I'm importing information to. Import is the command, we want to import stuff. ESSID is the name that we're telling it we want to import ESSID. And test ESSID is just a text file that contains the name of my target access point. I'm gonna hit enter, and that has been imported successfully. Now this is the step that takes the most time. We're gonna convert each password in the list. We're gonna combine it with the ESSID. So we're gonna create a list of PMKs from our word list. Again, we're gonna use arrowlib ng, and we're gonna put the name of the database that contains our word list, and then we're gonna tell it to batch, which is just convert each password, combine it with the ESSID, and create a PMK from each password in the list. Okay, so as you can see now, it computed all the PMKs. So that's the number of PMKs. That's the number of passwords that I have in my original list. And all of these passwords have been converted to PMKs, and they're stored in my database, which is testdb. And we can see that it took 366 seconds. So we're saving this time because in the scenario that we're working on, we'd be only waiting for the handshake. So we can do this while we're waiting to capture the handshake. Once we have the handshake, then we can crack it straight away using the PMKs, the already done PMKs, which will be much quicker. Let's see how we do that. We're going to use aircrackng, and we're going to use the option R to specify our database, which is called testdb. And then we're going to specify our handshake file, which is WPA or test handshake.cap. So very simple, aircrackng R to specify the testdb, and then we're going to specify the handshake file. Gonna hit enter. And as you can see, we cracked the password in much quicker. We cracked it in less than a second. So in the previous video it took 2 minutes and 16 seconds. Now it took less than 1 second. So it's much quicker because instead of aircrackng converting each password to a PMK, we are using a list of already made PMKs. So this is useful if capturing the handshake is taking a while because there is no clients connected to the target network. We have our PMKs ready, so that once we capture the handshake, we can crack it straight away. Now, every time we use aircrack-ng, regardless of the method, aircrack-ng will use the CPU, or the Central Processing Unit, to process the passwords and try them against the handshake. So basically, the processor or the CPU is what's being used in the cracking process. Now, this is usually the default behavior of most tools because the CPU is the brains of the computer, it's the central processing unit, and thus the default component that's used when the computer needs to process data. Now, if we pause for a second and think, a lot of computers also contain another processing unit, which is the GPU. The GPU stands for the Graphics Processing Unit, and it's built and designed so that they can carry out repetitive tasks very quickly. For example, rendering pixels on the screen is a very repetitive task because it literally loops over each pixel on screen and displays data in it. Therefore, the process of key cracking is very similar in its essence to rendering pixels on screen, for example. Basically, it's a very repetitive task because we go through the word list and we take each password in the word list and then try to test it against the handshake and see if it's valid or not. So it's a very repetitive task. And because the GPUs are optimized to carry out repetitive tasks very quickly, they're actually more efficient than CPUs when it comes to cracking. So, if you have a good graphics card, you can use that graphic card or GPU in the cracking process instead of the CPU, and that way you'll be able to go through the word list and carry out the cracking process much faster than if you would do it with the CPU. And that's the main goal of this lecture. I want to show you how to use the GPU in the cracking process instead of the CPU, and we'll see how fast that is compared to the speed that we were getting with the CPU. Now, first of all, before we do anything, you need to have a powerful GPU or at least a good graphics card. We're going to use a tool called Hashcat for the cracking process because aircrack-ng does not allow us to use the graphics card in the cracking. I'm also going to do this from a Windows machine because most GPUs have drivers for Windows and it'll be very difficult to install their drivers for Linux. So if you can install your driver for Linux, then it's okay. You can use Hashcat from Linux exactly the same way that I'm going to show it in this video, but I'm showing you how to do it from Windows because it's actually much easier to install the drivers for graphics card for Windows because most manufacturers release official drivers for Windows, whereas when you go to Linux, you might have to install third-party packages to get it to work. So I have the website here for Hashcat. I'm going to include it in the resources. Now, before you can use Hashcat, you'll have to download the driver requirements for your GPU. So you can see in here we have a list of the drivers that you need to download. So if you have an AMD GPU, you'll need to download the AMD Radeon software. For Linux, you'll have to download the AMD GPU Pro driver, and so on. Now I'm on Windows, so I'm just gonna highlight this and I'm gonna right click and search Google for it. Now you'll see the first result will come up with the right result, so I'm just gonna click it. And then you can see I can download it from here. Installing it is very easy. Just double click the downloaded file, then next, and then your computer will restart and you'll have it installed. Now I've already done all of that, so I'm going to go back to Hashcat and I'm going to go ahead and download the binary of Hashcat. And as you can see now, that's downloaded for me and it's gone in the downloads directory. So it's a zipped file, it's a 7-zip file. You'll need an archive manager to open it. I already have WinRAR installed, so I'm just going to double click it and that's going to be opened in WinRAR. Now I'm gonna click its directory here, click on extract to uncompress it, and I'm gonna choose to uncompress it in my C directory. I'm gonna hit OK, and that'll basically put the files for Hashcat in my C directory. Now the next step is gonna be converting my handshake to a file that's compatible with Hashcat. Now, when we capture the handshake, as we've seen in all the previous lectures, it's usually stored in a file that has a cap extension, so .cap. Now, Hashcat can't read the .cap files, so we'll have to convert this to a file that's compatible with Hashcat. Now, we can do that very easily using an online tool made by Hashcat. So I have it right here, and again, I'm going to include its link in the resources. Now, all you'll have to do is just go on Choose File, choose the cap file that contains the handshake, click on Open, and then put the network name in the ESSID field. Now, my network name is already stored in there, so it's UPC 723.762. I'm gonna click on Convert. Now, as you can see now, this automatically changed the file type to a HCCAPX file, and it automatically downloaded it for me as well. So if I go to my downloads directory, you can see that I have a new file here, and it has a HCCAPX extension. This is the extension that Hashcat can read and understand. Now I'm just going to rename this file, and I'm going to call it handshake so that it's easier for us to know. Now we're all set. I have my handshake here, and I also have my word list right here, which is called ROQ. And I'm just going to copy both of these files and put them in the same directory as Hashcat. So I put Hashcat in C, so it's in my PC, C, and it's called Hashcat. And I'm going to paste the word list and the handshake in here. Now we're all set. We have our word list and the handshake on the same directory as Hashcat binary. So now we're ready to use Hashcat, and all we have to do is we have to navigate here from Windows command prompt and then run Hashcat against this handshake with the dictionary that we just copied. So in the next lecture, I'm going to show you how to use Hashcat from the Windows command prompt to crack the handshake using the GPU instead of the CPU. Alright, now that we have everything ready, I have Hashcat already extracted in here, I have my handshake and my word list, so I'm ready to use Hashcat to crack the password. So first of all, we have to open the command prompt. So I'm going to go to the start menu. I'm going to type CMD to access my command prompt. Now I'm going to navigate to the location where I extracted Hashcat. So it was in C. So what I'm going to do is I'm going to do CD / to go all the way back to the root of the C directory. Then I'm going to do dir to list all available directories. This is the equivalent to ls in Linux. And as you can see now, I have a directory called Hashcat. So I want to navigate into that. And to do that, we're going to do CD Hashcat, and I'm going to press tab to autocomplete. And then I'm going to do dir again to list all the files in this current directory. And as you can see, I have Hashcat binaries in here. I have a 32-bit and a 64-bit binary. So you need to run the one that's compatible with your processor. And you can see I also have my handshake that I copied earlier. And I have my word list right there. Now to run Hashcat, we're going to do hashcat 64.exe, and I'm going to do -- help to see all the options and arguments that I can use with the tool. And as you can see, we get a big list that show us all the options and how to exactly use the tool. So at the top here, you can see the usage of the tool. So this is the default syntax that you should use the tool with. And this is exactly the same whether you use the tool from Linux or from Windows. So I'm showing you how to use it from Windows, but if you manage to install your graphics card drivers on your Linux, then you can use it the same way that I'm showing you here. So basically you need to give the tool name at the start, which is Hashcat. Then we're going to set the options, and you can see we have a big list of options here at the bottom. Then you're going to give the file that contains the data that you want to crack. and in our case it's the hccapx file, followed by the dictionary to run the attack, and in our case it's going to be called rawq. So I'm going to type in hashcat. Now because I'm on Windows, I'm going to have to type hashcat64.exe, but if you're on Linux, you're just going to do hashcat. Then we're going to have to set the options. And as you can see, we have a huge list of options that we can set. For each option, we can see the option name. We can see the type. So this is the value that this option can take. It can be a number, it could be a file, it could be a character. We can see the description. So this tells us what we can set with this option. And then we have an example at the end showing us an example of setting this option to a certain value. Now the first option or argument that I want to use is the -I. And in the description, you can see that this argument will show us information about the devices in this computer that can be used for cracking. So if we just do -I, you can see that we have two devices that we can use for cracking. We have my device number 1, which is the GPU, and it has an ID of 1, and you can see all the information about this device in here, including its memory. Then we can see we have another device, and that is a CPU, it's not a GPU. And again, you can see all the information related to this device. Now the next option that I want to use is the -M. Now this specifies the hash type, so the type of hash that you want to crack. Now the hash type is a number, so we have to give a number that corresponds to the hash that we want to crack. And if we scroll down, you'll see that we have a table called hash modes, and it contains all the hashes that we can crack and their corresponding number. So my target is a WPA hash or WPA2, and you can see that the number corresponding to this is 2500. So to set this option, we're going to do -M, and we're going to put 2500 to tell hashcat that I want to crack a WPA or WPA2 hash. Now the next option that I want to set is the -D to tell hashcat which device I want to use for cracking. So when we did -I, we seen we had two devices. We had number 1, which was my GPU, and we had number 2, which was my CPU. So I want to use the GPU for cracking, and therefore I'm going to do -D1. Now let's go up and have another look on the usage of the tool to make sure that we're using it properly. So we've already set hashcat, we've already set the options, and the next thing that we need to do is to give the capx file followed by the word list file. So we've already converted our handshake to the hccapx extension, and we placed it with the word list both in the same directory as hashcat, so that's our current working directory. As you can see here, I have my word list, and I have my hccap file right here. So my handshake is called handshake.hccapx, and my word list is called rawq.txt. So now our command is done, and let me go over it just one more time so that it's clear to you. First of all, we put the tool name, which is hashcat, and we put 64 because I have a 64-bit processor. So we're doing hashcat64.exe. We're doing -M to specify the hash type, and I'm putting 2500 because we went on the hash modes table and we seen that 2500 is the number for WPA and WPA2 hashes. Then I did -D, and I put number 1 to tell hashcat that I want to use device number 1 for cracking. That's my GPU, and I was able to see all my devices by doing hashcat-I. So we did that at the start, and we seen the list, and then we seen that device number 1 corresponds to my GPU. Then according to the usage of the tool, we've seen that we have to specify the handshake file after that. And I've already converted my handshake file to a HCCapX extension, and it's already in the same working directory. That's why I don't need to give a full path. And it's called handshake.hccapx. And finally, we have to give the word list, and again the word list in the same working directory, so I don't have to give a full path. And we just had to say rocku.txt, which is the name of my word list. Now I'm gonna hit enter. And Hashcat is gonna start the cracking process using my GPU instead of the CPU. Now, as you can see, we can actually pause and resume using the P and R if we want. And this way we'll be able to save our progress so that we can stop and come back to the cracking whenever we want. Okay, now as you can see, Hashcat is done. And it managed to get the password for me, and this is the network name, so that's the name of my network. And you can see that it managed to get me the password, which is 1234 ABCD. It took it 1 minute and 7 seconds to get to this password, and I've actually moved the password manually to the end of the word list to make sure that we go through the whole word list in this lecture. Now let me show you how big the word list is. It's actually not a small word list, it's not a huge word list, but it's big enough. So 1 minute and 7 seconds, it's a really good time to go through this word list. So I'm just gonna open it right here, and I'm gonna scroll all the way down. And as you can see, we managed to go through about 14 million passwords within 1 minute 7 seconds. Now my password is actually at the bottom, but it's not the very last password, so it's around the 14 million. But this is a very impressive time compared to the time that you'd get with the CPU. Again, 14 million passwords within 1 minute 7 seconds. Now, I'm not using the best GPU in the market, so if you have a better GPU, then you'll be even faster than this. But even with that, it's a very good time. So, as you can see, using the GPU will make the cracking process much faster than what it would be if we're using a CPU, even if your CPU is very fast. Now, just as an idea, or for something for you to try as practice, you can actually pipe crunch to Hashcat exactly the same way that I showed you how to do it with AirCrack. So you can practice that yourself, and Hashcat already supports pause and resume, so you'll be able to use huge word lists, you'll be able to save your progress, and you'll also be using your GPU for the cracking, so you'll be able to go through the word list much faster than what you would if you're using AirCrack NG.